This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to our discussion on analyzing projectile motion using Tracker software. We'll be exploring two documents that highlight the use of this free, open-source tool for physics education. For our 17-18-year-old audience, we'll keep things clear and engaging. Let's start with the first document. What immediately strikes you about the information presented?
The first document shows a snapshot of the Tracker software interface. It's clearly designed for analyzing video data, with features for tracking objects, viewing data in tables and plots, and even adding text and HTML pages. This suggests a very versatile tool suitable for various levels of analysis.
So it seems user-friendly. What kind of data can students extract from a video using Tracker, and how might that help them understand projectile motion?
Students can track the projectile's position, x and y coordinates, over time. From this, they can calculate velocity and acceleration, creating graphs to visualize the motion. This allows them to directly observe the effects of gravity and, potentially, air resistance on the projectile's trajectory. It's a powerful way to move beyond theoretical calculations and see the physics in action.
That's a great point about seeing the physics in action. The second document focuses on a specific projectile motion model. What are the key takeaways from this resource?
The second document provides a complete learning package around projectile motion and Tracker. It includes a video example, a briefing document summarizing key concepts, a study guide with short answer questions and essay questions, and even a FAQ section. It's a very comprehensive resource for teachers and students alike.
It sounds like a well-structured learning resource. The study guide includes both short answer and essay questions. What kind of deeper understanding do the essay questions encourage?
The essay questions push students to go beyond simple calculations. They encourage critical thinking about the relationship between displacement, velocity, and acceleration in projectile motion, the effects of air resistance, and application of Tracker to real-world scenarios. This deeper level of engagement is crucial for a solid understanding of the concepts.
Absolutely. The second document also mentions the importance of mathematical modeling. How does Tracker facilitate this process?
Tracker allows students to collect precise data from videos. This data can then be used to create and test mathematical models of the projectile's motion. By comparing the model's predictions to the actual data, students can refine their understanding of the underlying physics and the limitations of their models.
So it's not just about collecting data, it's about using that data to build and test models. This iterative process seems key to developing a deeper understanding. What are some of the limitations of using Tracker or potential challenges students might face?
One challenge could be accurately tracking the projectile in the video, especially if the video quality is poor or the projectile is small or moving quickly. Another challenge might be interpreting the data and building appropriate mathematical models. Students need to understand the underlying physics to make sense of the data they collect.
Good point. The need for a solid understanding of the underlying physics before using the tool is crucial. Let's return to the first document. What other aspects of the HTTP headers are noteworthy?
The HTTP headers in both documents provide valuable metadata about the server response. Things like the content encoding, zip indicate that the data is compressed, which improves efficiency. The access control allow origin is important for web security, allowing access from different domains. The last modified date helps with caching.
So these headers are essential for efficient and secure data transfer. They're not directly related to the physics, but they're crucial for the functionality of a website and the software. What about the content type header?
The content type, text/HTML, Charset UTF-8 header specifies that the response is an HTML document using UTF-8 encoding. This ensures that the web browser can correctly interpret and display the web page content. It's a standard header for web pages.
And what about the differences between the headers in the two documents? Are there any significant variations?
Yes, there are differences. The second document includes caching directives, cache control, expires, pragma, which are absent in the first. This suggests that the content in the second document is intended to be cached, while the first might be more dynamic. Also, the second document uses transfer encoding, chunked, indicating that the response body is sent in chunks, which is common for dynamically generated content.
So the differences in the headers reflect the different nature of the content being served. The first is a more immediate response, while the second is a more structured, potentially cached resource. Let's go back to the educational aspects of Tracker. What makes it a particularly valuable tool for learning physics?
Tracker bridges the gap between theory and practice. Students can see the concepts they're learning in action, which makes the learning more concrete and engaging. It also develops valuable data analysis skills, which are transferable to other scientific disciplines.
The hands-on aspect is definitely a strength. What advice would you give to a teacher considering using Tracker in their classroom?
I'd advise starting with simple experiments and gradually increasing the complexity. It's important to provide clear instructions and support to students, especially when they're first learning to use the software. The comprehensive resource in the second document would be an excellent starting point.
Excellent advice. The availability of comprehensive resources is a huge advantage. Finally, what are some other applications of video analysis software like Tracker beyond projectile motion? Thank you for this insightful discussion on using Tracker software for analyzing projectile motion. The combination of hands-on experimentation and data analysis makes it a powerful tool for physics education.